right, here we go. We are going to start going over the Unit 6 test review. Remember, this is over systems. We learned 3 different ways to solve these systems: graphing, substitution, and elimination. And we're going to look at all 3 of those ways. Remember, with these systems, you can actually solve any of these by using any of those 3 methods, but sometimes it's easier to use one method over the other. So we're going to think about that as we go through this. All right, number 1. These say solve the systems by graphing. So to be able to graph a line, they need to be in y equals mx plus b. So I'm going to subtract this x in this first equation. Remember, with these videos, if we go too fast for you, then pause it and rewind or whatever you need to do. But I don't want this to be an hour and a half long video, so I'm going to keep going. All right, so I have y equals negative x minus 2. So I'm going to go ahead and graph that. I'm going to start at negative 2, and I'm going to go down 1 over 1. I'm just going to get, 5 or 6 points on here. 7, 8 points, whatever. Okay, and there's my first line. Okay, now my second line, I need to add x to both sides. So I have y equals x plus 6. So I'm going to start up here at 6. 1, 2, 3, 4, 5, 6. And my slope's positive 1. So I need my slope to be going uphill. Okay, as soon as you see where those 2 lines intersect, you can really just stop there, because that's what we're looking for. So the intersection is going to be at that point right there, which means the answer, the solution to this is negative 4, 2. All right, number 2, this first line, I'm going to have to subtract x. Actually add y to both sides if you'd rather do that. So I have negative y equals negative x. Divide both sides by negative 1. So I just have y equals x. Okay, my y-intercept here is actually just 0. So I'm going to start at 0. My slope's 1. So I'm going to go up 1 over 1, up 1 over 1. Okay, I'm going to get that line drawn. Okay, the second line, I got a little more work I need to do to it. So I'm going to subtract 5x from both sides. So that gives me 2y equals negative 5x minus 7. Divide everything by 2. And that gives me y equals negative 5 over 2x minus 7 over 2. So a little nasty here. But that's okay. Negative 7 over 2, that's actually just negative 3.5. So that's where I'm going to start. 1, 2, 3, and then 0.5. So negative 3.5. Okay, and our slope here is negative 5 over 2. And actually here, it might be easier. Well, we're just going to keep it at negative 5 over 2. Okay, so I'm going to go up 1, 2, 3, 4, 5 over 2. So you can see that they intersect right here. Okay, now the problem is it looks like it's a pretty point on the graph that I drew, but I don't know for sure. So I'm going to check this in my calculator, and I think it's a good idea to review how to do that anyways. So I'm going to go to my calculator. I'm going to go to y equals. If there's anything in there, clear it out. And I'm going to type these in. So I have y equals x in there. And then I also have y equals, I'm going to put my fraction in parentheses. So negative 5 over 2x minus 7 over 2. All right, so there we go. Enter that in and graph it. Make sure this graph looks like yours. Now you can do this on any of the graphing ones, or any that are in y equals actually. Okay, now I'm going to do second trace because I want to calculate something. Remember, we want the intersections, number 5. And then you're going to hit enter 3 times. 1, 2, 3. And there's our intersection. Negative 1, negative 1. Which is what it looked like ours probably was. But again, I couldn't see that it was exact. And I just wanted to check that in my calculator. You'd probably want to check all of these anyways. All right, number 3. Now these say to solve by substitution, and notice this one's already set up to where substitution would be the easiest anyways. Okay, so I know what x is equal to. Now I'm going to show you all how I like to work these. You may set them up differently. So I'm going to take what x is equal to, and I'm going to substitute that in for x. So I have 5. Now that box is going to go in for x. So y plus 9, and then you write out the rest of that equation. Now we're going to solve this. So distribute your 5. So I have 5y plus 45 minus 3y equals 7. I have a 5y and a minus 3y. So that's 2y. I'm going to go ahead and subtract that 45 from both sides at the same time. Okay, and 7 minus 45 is a negative 38. Divide both sides by 2. And y is negative 19. Okay, now we have to take that negative 19 and plug it back in. And I think the easiest place to plug it back in is going to be that y right there. Okay, you can plug it into either y, it does not matter, but plug it into the one you think looks the easiest. So I'm going to have x equals negative 19 plus 9. So x is going to equal negative 10. So our solution here is negative 10, negative 19. All right, number 4. Now the way that this is set up, I'm not really ready to do substitution yet. So I need to solve for a variable. Just the way this is set up, I'm going to go ahead and solve for the second y, because all I have to do is add x to both sides. So I have y equals x minus 5 down. So what I'm going to do is I'm going to take what y is equal to, and I'm going to substitute that. Make sure it goes back into the other equation. Okay. So I have 2. Now I'm going to substitute that box in. So x minus 5, and then plus x equals negative 4. Keep solving this. So distribute your 2. 2x minus 10 plus x equals negative 4. Now I have a 2x and an x, so that's 3x. I'm going to go ahead and add that 10 to both sides. So I have 3x equals 6. Divide both sides by 3, and x is 2. Okay, now I need to take that 2 and plug it back in. Now it does not matter which place you plug it into. I can plug it into this first equation, the second equation, or what would be the easiest is that third equation where we solve for y. So I have y equals, now we said x is 2, so 2 minus 5, which means y is negative 3. So our solution here is 2, negative 3. Okay, number 5. All right, so same thing here. I don't have anything solved for. The easiest thing to solve for is going to be this x, since it has a 1 in it, that second x. So I'm going to subtract 4y, and I get x equals negative 4y plus 10. Now I'm going to take what x is equal to, and I'm going to substitute that into the other equation for x. So I have 3, and that's negative 4y plus 10 is going to go in for x. Minus 5y equals 13. Keep working this out. So distribute the 3. I have negative 12y plus 30 minus 5y equals 13. Okay, I have a negative 12y and a minus 5y, so that's negative 17y. I'm going to go ahead and subtract that 30 from both sides, cut out a step there. So 13 minus 30 is negative 17. Divide by negative 17. With all these crazy numbers, we end up with y as 1. Okay, now I'm going to take that, I'm going to plug it back in. Now you can plug it into the first equation, the second, or the third where we solve for x, which is going to be the easiest. So x equals negative 4. I'm going to plug 1 in for y plus 10. So I have negative 4 plus 10, which means x is equal to 6. So my solution here is 6, comma 1. Now this is a problem that the way that it's set up, elimination would probably be the easiest way to solve it since both of those equations are already in standard form. But since we're learning substitution in this section, we wanted to go ahead and solve that by substitution. But if you got to choose, you'd probably want to choose elimination. number 6. Solve the following systems using elimination. All right, here we go. This is the easy one. Okay, now remember it has to be in standard form. That just means your x, it needs to be your x, your y equal to your number. Okay, and they all need to be lined up, and then you need to have opposites. So right here, I have opposites on my y's. So those are going to eliminate. If I add down, I have 4x minus 2x is 2x, and then 5 minus 7 is negative 2. Divide both sides by 2, and x equals negative 1. I'm going to take that, plug it back into either equation. I'm just going to plug it back into that first one. So I have 4 times negative 1 minus 3y equals 5. So that's negative 4 minus 3y equals 5. I'm going to add 4 to both sides. So I have negative 3y equals 9. Divide both sides by negative 3. And we get y is negative 3. So our solution here is negative 1, negative 3. Remember, you can check these too. You can check every single one of these systems problems. You just have to plug both of those numbers back in, and those equations need to be true. All right, number 7. Now, if I'm going to solve this by elimination, I have to get everything lined up, which means I need to get this 3x to the left side. So I've got to move it over. So that's going to give me negative 3x plus 2y equals 6. And then I'm going to write that other equation back under it. Okay, so it's all lined up. We want to check for opposites. We do have opposites on our x. So we can add down and eliminate those. I have 2y and 4y, that's 6y. 6 minus 6 is 0. Okay, I still have to divide both sides by 6. Don't see a 0 and think this means no solution. It doesn't. That just means 0 divided by 6 is 0. And then take that 0 and plug it back in. To me, I think the first equation is going to be a little bit easier. So I'm going to have 3x plus 4 times 0. You can have probably already done that part in your head. So I have 3x, 4 times 0 is 0. So I have 3x equals negative 6. Divide by 3, x is negative 2. Which means our solution here is negative 2, comma, 0. All right, number 8. Okay, so we make sure everything's lined up, and it is. Now, I don't have opposites right now, so I need to get opposites. And to me, the easiest thing to do would be to multiply the second equation by 3. So that's going to give me a negative 6x plus 9y equals negative 15. And I'm going to write that other equation under it. Okay, now if you multiply that through and you don't have opposites, then you didn't do it right. Okay, and if you're not sure why I multiplied everything by 3, make sure you ask somebody how to do that. So now I'm going to add down. My x's eliminate. I have 9y minus 2y is 7y. Negative 15 plus 1 is negative 14. Divide by 7, and I get y is negative 2. Okay, now I'm going to plug back in to either one. I'm just going to plug it into that first one. So I have 6x minus 2 times negative 2 equals 1. So 6x, that's going to be a positive 4, equals 1. Subtract the 4, so I have 6x equals negative 3. Divide by 6. Be careful on these fractions. Some of y'all are going to look at that and say that's negative 2, where really it's negative 1/2. So my solution here is going to be negative 2, oops, nope, that's not my x. Negative 1/2, comma, negative 2. All right, number 9. These do take a while, so if you don't need help on one, don't watch the whole video because it's going to take forever. All right, number 9. So I need to get these to where they would be opposite. So you need to choose if you want to get rid of your x's or your y's. I'm going to choose my x's. So I'm going to multiply this first one by 2 and the bottom one by negative 9. That's going to get me opposite x's. So I'm going to have 18x minus 16y equals 8, and negative 18x plus 27y equals 36. Now I'm going to add down. My x's are going to be gone. I have negative 16 plus 27. That's 11y. And I have 8 plus 36 is 44. Divide by 11. So y is 4. That's not bad. Okay, I'm going to plug that back in. So I'm going to just use that first equation. I have 9x minus 8 times 4 equals 4. So 9x minus 32 equals 4. Add the 32 to both sides. So 9x equals 36. Divide both sides by 9. So x is also 4. So our solution here is 4, 4. All right, so that's elimination. Now this last section on the front page is going to be a little bit easier because you can solve using any method. So you're going to want to solve using the method that looks the easiest from the beginning. Okay, so number 10 is already set up in standard form, so I would do elimination. Okay, but nothing would eliminate right now. But if I just make one of those y's negative, they would eliminate. So I'm going to multiply this bottom equation by negative 1. So that gets me 3x minus y equals 8. And I'm going to write that other one underneath it. And I'm going to add down. So the y's are gone. I have 4x equals 12. Divide by 4. So x is 3. I'm going to plug that back in to that top equation or the second one, but the first one looks easier. So I have x, which is 3, plus y equals 4. Subtract 3, so y is 1. So my solution here is 3, 1. Okay, number 11. Now the way this is set up, since I already know what y is equal to, substitution is probably going to be the easiest way. So I'm going to take what y equals and I'm going to substitute in for y. So I have negative 6x plus 3. Then I'm going to substitute that box in. Okay, I'm going to distribute the 3. So I have negative 6x plus 6x minus 12 equals negative 12. Now look what happened here. I have a negative 6x and a 6x. That's going to be 0. So I have no more x's. All I'm left with is negative 12 equals negative 12. Notice our variables got completely eliminated. If that happened and this is true, negative 12 does equal negative 12, then the answer is IMS. Infinitely many solutions. IMS. Okay, number 12. Now the way this one is set up, okay, it's already set up for elimination. Really easy. Everything's even already opposites. Okay, so I'm going to add down right now. So the x's are going to be gone. Now look at the y's. 3y minus 3y, those are also gone. So all I'm left with is 0 equals 9, which is not true. So our answer here would be no solution. All right, solve the following system. Okay, so what you have to notice here, okay, this isn't necessarily a square. Let's just say it's a rectangle. Okay, so if I look at this, I know that 8x plus 5y, that's going to be the same as this side. So I have 8x plus 5y is equal to 94. And then I also know that negative 2x plus 5y is going to equal this other side, which is 14. Now the way that this is set up right now, I can't do elimination because those y's are not going to eliminate. Okay, so I'm going to flip the signs of one of these. I'm going to multiply one of them by negative 1. All that's going to do is flip the signs. Okay, so I'm going to make this a negative 8x, a negative 5y, and a negative 94. And I'm going to add down. So that's negative 10x. The y's are gone, and the negative 94 plus 14 is going to be negative 80. Divide by negative 10, so x is 8. Take that, plug it back in. To either one, I'm going to plug it into that 8x plus 5y. So I have 8 times 8 plus 5y equals 94. So I have 64 plus 5y equals 94. Subtract that 64. So I have 5y equals 30, divide by 5, so y is 6. So our solution here would be 8, 6. This would be a really easy one to check, so make sure you do that on your test. 14, solve the following system, then find 2x plus y. I cannot find 2x plus y until I know x and y. So I have to find that first. Now the way that this is set up, elimination is probably the easiest. So I'm going to take, substitution. So I'm going to take what x is equal to, I'm going to substitute it in for x. As if we haven't done that enough here. So we've got 4y plus 5 times 8y plus 3 equals 15. Should keep working that out. So 4y plus 40y plus 15 equals 15. 4y and 40y, that's 44y. I'm going to subtract that 15 from both sides. So I have 44y equals 0. Notice here's another 0. This does not mean it's no solution. I still have a variable. So I'm going to divide by 44. So y is going to be 0. I'm going to take that, plug it back in. Now, the second equation is going to be the easiest to plug it in. So I have x equals 8 times 0 plus 3. So x is equal to 8 times 0 is 0 plus 3 is 3. So our solution here would be 3, 0, but that's not what it's asking for. It's asking to then find 2x plus y. Okay, well x is 3 and y is 0. So I've got 2 times 3 plus 0. 2 times 3 is 6 plus 0 is 6. So that is our actual answer here. Okay, number 15, solve the following system of inequalities. Okay, so this first one is already nice. It's already in y equals. Remember with these inequalities, we're looking for where the shadings overlap. Okay, so this first one, I'm going to start at 1. I'm going to go up 2 over 1. Okay, since it's greater than or equal to, notice it has the solid line under the sign, which means it's going to be a solid line. Okay, and I need everything greater than. That means I need everything above this line. So that's everything up here. Okay, I'm going to do this other one in another color so you can see this. So our y is less than negative x plus 4. So I'm going to start at 4, and my slope's negative 1. So I'm going to go down 1 over 1. Since this is less than, this is actually just going to be a dashed line. And I need everything less than that, so I need everything under it, which would be everything under here. So the actual solution to this, where you would want to shade really dark, or at least we need to be able to tell what you're shading, would be everything in here. So that would be our solution here. Okay, number 16, y is greater than or equal to negative 2. Now notice we just have a y here, we don't have an x, which means this is going to be Hoy Bucks. Okay, so I'm going to use Hoy here. So I'm going to go to negative 2 on the y-axis. It's going to be a solid horizontal line. And I need everything greater than that, so everything above it. Okay, this other line is not solved for y, so I need to solve for y first. I'm going to subtract 2x. That gives me 3y is greater than negative 2x minus 6. Divide everything by 3. So I have y is greater than negative 2/3 x minus 2. So I'm going to start at negative 2, where we started on the other one. And I'm going to go down to the right 3, or up 2 and to the left 3. Remember, this line needs to be going downhill. This is going to be a dashed line. And I need everything greater than this. So it's going to be everything above it. So my solution here is where the two shadings overlap, which would be everything in this area. There you go. All right, number 17. Write a system of inequalities to describe the graph. All right, let's look at that red line first. Okay, so I'm going to have y. Notice everything's being shaded under that, which means it's less than. It's also a solid line, so I need the solid line under that sign, less than or equal to. Now we need a slope, okay? I do know it's negative because it's going down. Pick 2 pretty points on here and do your rise over run. So I'm going to rise 2, run 1, which means my slope's -2. Then we have our x, and then our y-intercept is here at 1. So there's that first line. The blue line, I'm going to have y. Notice everything is shaded above the blue line. So that's greater than. It's just a dashed line, so it's just greater than. Now I need a slope. So pick 2 pretty points. I can rise 1, run 1. So that's just 1, which is just x. And then my slope is at -2, so -2. Remember, you can check these too. Those are in y equals. So you can type that in your y equals in your calculator and graph it. Make sure it's the same line. Number 18, for the system of linear inequalities on number 17, which of the following is or are a solution? Okay, for it to be a solution, it can't just be in one of the shaded areas, it has to be in both. So it has to be in the double shaded area. So Roman numeral 1, so -2, -1. Okay, well -2, -1, -2, -1, that would be right there. So that's in the shaded area. 2, 0. Now be careful here, that is on a dashed line. Okay, and it's not in the shaded area, so it doesn't matter. So that's out. 3, -2. So 3, -2, that's not in the shaded area. Then I have -1, 3. So -1, 3. Okay, now be careful here. It is in the shaded area. It's also a solid line, which means it is a solution. If this was in the shaded area, but it was on a dashed line, it would not be a solution. So here it looks like 1 and 4 are our solutions, so D. All right, 19. Given points 7, 5, 8, 3, and 0, -1, which statement is true? All right, so look at our answer choices. They're all talking about parallel and perpendicular lines. Okay, so I need to find the slopes of these. All right, so let's start with PQ. Okay, so I'm going to do y2 minus y1. So that's going to be 3 minus 5 over 8 minus 7. So it's going to be -2 over 1, which means our slope is -2. All right, now let's do QR. So QR, I'm going to have -1 minus 3 over 0 minus 8. So that's going to be -4 over -8, which means our slope is 1/2. And then if we do PR, that's going to be -1 minus 5 over 0 minus 7. So that's -6 over -7, which is just 6 over 7. Actually, did I just do this backwards? No, I didn't. Okay, perfect. All right, so here we go. Now PR, it has nothing to do with those other ones, so that's probably not going to be in our answer. Remember, parallel lines have the same slope. We don't have any lines with the same slope here. So F and J are out. It's parallel, same slope. Perpendicular means we need opposite reciprocal slopes. Okay, and we do. -2 and 1/2, those are opposite reciprocals, which means PQ and QR are perpendicular. So G. All right, number 20. Write a direct variation equation if x is 6 and y is 9. All right, so direct variation is y equals kx. Okay, now if you have a different teacher, they may teach this a little bit differently. So if you have a question on this, make sure you ask them. All right, so I'm going to plug in everything that I know. I know y is 9 equals, we don't know k, and we know x is 6. And I'm going to solve this for k. So I'm going to divide both sides by 6, which means k is 3 over 2. Now it wants us to write a direct variation equation. This is our k, that's what we need. It's kind of like our slope, or it is our slope actually. So I have y equals 3 over 2x. That's my direct variation equation. 21. Okay, so this is a long one. Write the equation of a line in all three forms: slope, intercept, point, slope, and standard that passes through the points -1, 1, and 2, 0. All right, to be able to put it into any of these forms, we need a slope first. So I'm going to find the slope of this. So I'm going to have 0 minus 1 over 2 minus a -1, which is going to change to +1. So that's -1 over 3. All right, now notice what we have here. We have a slope and we have points. Point, slope. So I'm going to put it into point, slope first. Now pick either one of these points. Now if you can tell that 2, 0, that's actually our y-intercept. So if you can tell that from the very beginning, that's great. If not, this needs to go in point, slope. Okay, pick either one of these points, but if it were me, I would pick the point that has a 0 in it. All right, so here's point, slope. So I'm going to have y minus my y value, which is 0, equals my slope, which we found was -1/3. Then I'm going to have x minus 2. All right, there we go. There's our point slope. Now, let's get it into slope intercept. Okay, so y minus 0, that's just going to be y, equals, I'm going to distribute this 1/3. So I'm going to have -1/3 x, and then -1/3 times -2 is going to be a positive 2 over 3. Okay, now standard form is the one that y'all think is the hardest, and it's not hard at all. All you need to do is get x and y on the same side. Okay, then there's going to be a couple rules that are involved, but get x and y on the same side first. So what I'm going to do is I'm going to add this 1/3 x, and I'm going to move it over here to get with the y. Because remember, your x needs to be positive. So I'm going to have 1/3 x plus y equals 2/3. Okay, we're almost there. Okay, we have x and y on the same side. Make sure your x is positive, and it already is, so we don't have to worry about that. But remember, you have to get rid of fractions. And how do we get rid of a 1/3 and a 2/3? We're going to multiply by 3. Okay, so if I multiply everything by 3, 3 times 1/3, that's going to leave me with 1. So x plus 3 times y is 3y. And then 3 times 2/3 is going to leave me with that 2. So there we go. There's standard form. So all you have to do is get x and y on the same side, but if you have fractions, you have to get rid of those fractions. All right, number 22. Write a linear regression equation for the following information and predict the weekly earnings for a person in 2014. Round to the nearest thousand. Now, to save some time, I went ahead and already typed this in my calculator. Okay, to be able to get the correct y-intercept, when you're looking at these years, you're going to want to make this year 0, year 1, year 2, year 3, year 4. Okay, if you don't do it that way, your equation is going to be different, but when it asks the question about the earnings for 2014, your answer should still be the same. So if you forget to do that, it's not the end of the world. Okay, so I've already typed this in, so I'm going to go to Stat 1 because I want to edit my table. Okay, I've already typed those in. So from here, I'm going to go to Stat. I'm going to right-click over to Count. I want a linear regression to number 4. I'm going to go down to Store. I'm going to hit Alpha, Trace. What this is going to do is it's going to store it for us in our y equals. All right, so there's my equation, 11.729. So y equals 11.729x plus 307.96. If you still do not know how to do that, you need to learn because the stuff's not going to go away. Okay, now we need to figure out the weekly earnings for a person in 2014. Now notice we used 0, 1, 2, 3, 4 for our years. So I'm not going to go find 2014 in my table. I need to figure out how many years have gone by. Okay, to do that, I'm going to do 2014 minus what we started at, which was 1987. Okay, and if I do that, that's 27 years have gone by. So I'm going to go to my calculator. I'm actually going to check something real quick. I need to clear this out. Okay, I'm going to go to my table. And what I need to find in here is 27. Now, if you don't want to scroll all the way down to 27, you can change where your table starts. So you can hit second window, because we want to change where our table starts, to 27. Now you go back to your table, and you can see in 27 years, the average weekly earnings was 624.64. So 624.64. So that's the question it's asking. All right, 23. The formula to find surface area of a prism is S equals 2B plus pH. Solve the formula for B. Now, for some reason, these get missed a lot too. Okay, all we are trying to do here is get B by itself. Okay, just think about it. That was X. What would you do to get X by itself? So the first thing I need to do is if there's anything being added or subtracted, I need to move that. So I need to subtract pH. Okay, and that's all one thing, so I need to move it all together. So I have S minus pH is equal to 2B. Okay, now I'm still trying to get that B by itself. How do we get the 2 off? We divide by 2. You can actually just leave your answer like that. S minus pH over 2. Okay, I am doing the second half of this review with no voice, so I apologize for that. All right, number 24. For the line graph below, which of the following are true if the slope is changed to 1/2 and the y-intercept stays the same? Okay, so we have these 3 different choices. 1, the new line will be parallel. 2, the new line will be perpendicular. Or 3, the new line will intersect. Okay, well, let's talk about what these would mean. If the new line was parallel, parallel means same slope. Okay, and it says that the slope is being changed, which means it can't be 1. 2, the new line will be perpendicular, maybe, and the new line will intersect, maybe. So what we need to do is we need to figure out what the original slope was, and then we're going to change it to 1/2 and see what happens with those slopes. Okay, so we're going to go to this line over here, and we're going to find 2 pretty points on this line. So I'm going to use this point and this point. Okay, now I'm going to do rise over run. So I'm going to go up 2. So it's going to be 2 over run 1. But this is negative because it's going downhill. So my slope here of the original line is -2. And they're wanting me to change that to 1/2. Okay, if I have different slopes, my lines will intersect at some point. So it's definitely 3. Okay, now with perpendicular, you have to remember that that means it's opposite reciprocal slope. Opposite reciprocal slopes. -2 and 1/2, those are opposite reciprocals, which means they are perpendicular. So it's D. Number 25, suppose a model airplane club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 for research and writing. The price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? Okay, so to break even, that means we need our expenses to equal our sales. Oh, that's not how you spell sales. To equal our sales. Okay, so all of our expenses, we have 90 cents, so 0.9 for each. When you see that word each, that means we need to put an X. So 0.9X plus 600, and that's going to equal our sales, which is $1.50 per. When you see that word per, that means you need an X. Okay, and then you're going to solve this out. So we're going to subtract 0.9X from both sides. Okay, that's going to give us 600 equals 0.6X. Divide both sides by 0.6. So X is 1,000. So you'd have to sell 1,000 copies to break even. Number 26, given the following points, which lines will be parallel, perpendicular, or neither? And it says to hint, we got to find the slopes of all these. All right, so this is going to take a little bit of time. All right, so let's start with AB. Okay, so that's going to be 4 minus 5 over 9 minus 8. Because we do y2 minus y1 or x2 minus x1. All right, so that's negative 1 over 1, which means the slope is negative 1. Okay, now we're going to do, let's go BC. So BC. Okay, that would be 0 minus 4 over 1 minus 9. So that gets me negative 4 over negative 8, which simplifies to 1/2. Now CD is going to be 2 minus 0 over 0 minus 1. So that's 2 over negative 1, which means it's negative 2. And then the last one is AD, which would be 2 minus 5 over 0 minus 8, which is negative 3 over negative 8, which is going to come out to be positive 3 over 8. All right, so remember, parallel lines have the same slope. We don't have any lines here with the same slope. Perpendicular have opposite reciprocal. Okay, well, if I look at 1/2 and I look at negative 2, those numbers are opposite reciprocals of each other. Therefore, BC is perpendicular to CD. That sign right there means perpendicular. BC is perpendicular. There's no lines that are parallel, and it's not neither. Okay, 27. Describe in words what a no solution and infinitely many solutions would look like graphically and mathematically using substitution or elimination. All right, so let's talk about no solution first. Okay, remember what a solution is. A solution is where two lines intersect. So, if two lines don't intersect, that means they're parallel. So no solution would be parallel lines. Okay, and then with substitution or elimination, it's going to be when you completely get rid of your variable. So let's say all your variables cancel out, okay, and you end up with something that's not true. So let's say I work out a problem and I end up with 2 equals 6. That's not true, so that would be no solution. It's only going to be no solution if you get rid of your variables. Okay, for infinitely many solutions, okay, that's going to be two lines that intersect an infinite amount of times, which means it's going to be the same line. Okay, and then same thing with the no solution. If you completely get rid of your variables, but this time the statement has to be true. So if you end up working it out and canceling out the variables and you end up with 2 equals 2, which is true, then that would be. Okay, so this is when it's true, and this would be when it's false. Okay, so that's basically what you need to know there. All right, number 28. What part of slope-intercept form is the rate of change? We have to know what rate of change means. Rate of change means slope. So what part of slope-intercept form is the rate of change? It's the slope or it's the m in the equation. And y equals mx plus b. It would be the m. 29. Explain the differences between parallel and perpendicular lines in terms of their slopes. What form of an equation of a line is easiest to determine slope? Okay, so we know parallel, we've talked about this already. Parallel is the same slope. Okay, and perpendicular is opposite reciprocal. I know we ask y'all this a lot, but it's really important. So you have to make sure you remember parallel means same slope, and perpendicular means opposite reciprocal slope. Okay, and what form of an equation is easiest to determine the slope? It would be y equals mx plus b. All right, on these next, however many there are here, I'm not sure. Okay, it says write a let statement and solve your system using any method. Okay, these are going to take a little while to work through. So on all of these, we need to write a let statement, we need to write our equations, and then we need to write our solution. Okay, so on number 30, all right, let's read this. We got tickets for admission to a high school football game cost $3 for students and $5 for adults. During one game, $2,995 was collected from the sale of 729 tickets. How many students and adults attended the game? Okay, so I'm going to say X is students. I don't like to use S's because they look like 5. X is students, and I'm going to go ahead and use A for adults because that just makes sense to me. All right, now, so we've got our let statement. Now I need my equations. So I'm going to have one equation that has to do with the value of the tickets and one that has to do with how many we have. Okay, so we have a total of 729 tickets, which means I have student tickets, which is X, and adult tickets, which is A, and I have 729 of them. Okay, now I need one that has to do with the value. I have $2,995 altogether. Okay, so a student ticket is $3, so that's 3X. An adult is $5, so that's 5A. And if I have value here and value here, then it needs to equal value. So that's 295. Okay, now the easiest way to solve this would be elimination. So I'm going to try to eliminate my x's, which means I'm going to multiply it all by -3. So that's going to give me -3x minus 3a equals 729 times -3 is -2187. And now I'm going to add down. So my x's are going to eliminate. I have 5a minus 3a is 2a. And then 2,995 minus 2,187. That number is 808. Divide both sides by 2. So I have adult tickets. I have 404 of them. Okay, now we have to plug that back in and get the other number. Doesn't matter into which equation, but do the easiest one. So I'm going to do x plus, I'm going to plug 404 in for a. Subtract 404. And so the amount of student tickets is 325. There's our two answers. All right, 31. 40 adults and 26 kids went to see a movie on the opening screening, and the revenue for the showing was $486.70. The next showing, 20 adults and 31 kids went to see the same movie, and the revenue was $332.45. How much was an adult ticket and how much was a kid ticket? All right, here we go. So we have our let statement. I'm going to let A be adult, and I'm going to let K be kid. Okay, now we need our equation. So I have 40 adults, so 40A plus 26 kids, so 20K, and that was 486.7. Then I had 20 adults and 31 kids, and that was 332.45. Now the way that this is set up, elimination is going to be the easiest way. So I'm going to multiply this second equation by -2. That's going to get me my A's can eliminate. So that's going to get me -40A minus 62K equals okay, hold on. I want to make sure I get the right number here. 332.45 times -2 is -664.9. Okay, so now I'm basically done with that equation. Now I'm going to add down. I don't really want to rewrite all these, so I'm just going to add straight in. So my A's are going to be gone. I have 26 minus 62. Okay, so 26 minus 62 is -36K equals, if I do 486.7 minus 664.9, that's -178.2.
divide by negative 36. And a kid ticket is going to be $4.95. Okay, if I take that and plug it in, okay, I'm going to plug it into the original, the 20A plus 31K, just because it's smaller numbers. So I have 20A plus 31 times 495 is 153.45 equals 332.45. Subtract that number. So I have 20A equals hold on, gotta get that number. 332.45 minus 353.45 equals 179. Divide by 20. And an adult ticket is $8.95. And y'all make sure these numbers make sense. Okay, if you would have gotten an adult ticket was cheaper here, you may have done something wrong. So just make sure they make sense. 32. The length of a rectangle measures 6 more than the width. The perimeter of the rectangle is 38. What are the dimensions of the rectangle? All right, so here we go. I'm going to say let L be length and W be width. Okay, now I need my equation. So it says the length measures. That might as well say that length equals. So I've got L equals 6 more than the width. So 6 plus, we said width was W. Now it's saying the perimeter is 38. Well, you have to know the perimeter formula, or it's on the formula chart. So I've got 2L plus 2W is 38. Now the easiest way to solve this is going to be substitution. Since I know what L is equal to, I'm going to take that and I'm going to substitute it in for L. So I've got 2, and do not try to distribute this in your head because you will mess it up. Make sure you write it all out. Okay, so that's going to give me, if I distribute the 2, it's going to give me 12 plus 2W plus 2W equals 38. So 12 plus 4W equals 38. Subtract 12. So 4W equals 26. Divide by 4. Our width here is going to be 6.5. Okay, and I know that sounds like a funny number, but at least it's a nice decimal, so that's okay. I'm going to take that and plug it back in. I would plug it in to this first equation. Okay, that's going to be the easiest place to plug it into. So I have length equals 6 plus width, which is 6.5, which means my length here is 12.5. So there's my answer. Don't think that you can shortcut this and just make up any numbers you want that work. Okay, remember the numbers have to work in both equations. So you can't just think of numbers that would add up to be 38. They also have to work in that other equation. Okay, number 33. Mrs. Smith made a bank deposit of $157 in $1 and $5 bills. If her deposit consisted of 57 bills, how many of each kind did she have? All right, so we're going to say let. We've got 1s and 5s. So I'm going to say let O, but I'm going to put a line through it so I know it's not a 0. Be 1s, and I'm going to let F be 5s. Okay, so this is kind of like the tickets problem. We need one equation that has to do with the total amount that we have, and one that has to do with the total value that we have. Okay, so first it says we have 57 bills. So I have 1s, which is O, plus I have 5s, and I have 57 of them. So that's my first equation. Now I need my value equation. So 1s, that's just 1, so just O, plus a $5 is 5, and I have $157 worth. Okay, now notice our O's here. Those are almost ready to eliminate, but those don't eliminate right now. So don't think you can just cancel those out. They don't cancel out. One of them needs to be negative. So what I'm going to do is I'm going to multiply one of these equations by -1, which basically means I'm just going to flip the signs. So that's all I'm going to do. Now I can add down. So the O's will be gone. I have -1f plus 5f, that's 4f. And I have -57 plus 157 is 100. Divide by 4. So I have 25 $5 bills. Now I'm going to plug that back in to figure out how many ones I have. So I have ones, plus I have 25 $5 bills, and I have 57 of them. Subtract 25. So I have, in $1 bills, I have 32. And these are really easy problems to plug back into your calculator and make sure they make sense. Okay, so make sure you do that on these. All right, 34. Suppose you have 12 coins that total 32 cents. Some of the coins are nickels and the rest are pennies. How many of each coin do you have? All right, so I'm going to say let P be pennies and N be nickels. Okay, so I'm going to say I have 12 altogether. So I have P plus N equals 12. And then I have 32 cents altogether, so that's my value equation. Now a penny is 1 cent, so that's just P. A nickel is 5 cents, which is 5N. And since I've made those whole numbers, I'm going to keep 32 cents as 32. Now keep in mind that's really 0.32, but I've moved the decimal over twice to make these all whole numbers. Now this is almost ready for elimination, but one of these P's needs to be negative. So I'm going to flip all the signs of the first problem, or the first equation. Like I've multiplied everything by -1. Now I'm going to add down. So the P's will be gone. I have -N plus 5, that's going to be 4N. And -12 plus 32 is 20. Divide by 4, I have 5 nickels. And we have 12 altogether, so it's pretty easy to figure out that I have 7 pennies. If this is going too fast, pause it. All right, 35. Let's just set this one up, and we're not going to solve it. Let's just set it up. Or actually, we will solve it. We're almost done. All right, the sum of two numbers is 6 less than twice the first number. Their difference is 10 less than 4 times the second number. Find each of the numbers. All right, so I'm going to say let X be my first number and Y be my second number. Okay. All right, the sum of two numbers is, there's the is, that's important to find. So the sum of two numbers, so that'd be X plus Y, is 6 less than. Remember less than, those are turnaround words. So you're going to write this in the opposite way that you read it. So I have twice the first number, which would be 2X, and I need 6 less than that, so minus 6. Their difference is, so their difference, that would be X minus Y, equals 10 less than 4 times this second number. So I have 4 times Y, and I need 10 less than that, so minus 10. Now you cannot do elimination on this until it's in standard form, which means you need to get all your X's and Y's on the same side. Okay, so in this first equation, I'm going to subtract 2X and move it over. Okay, that's now going to get me, because that's 1X minus 2X. So that's a negative X plus Y equals negative 6. And then this other equation, I need to move the 4Y over. So I'm going to subtract 4Y. And that gets me X minus 5Y equals negative 10. Now this one's really nice. It's already set up for elimination. The X's are going to cancel out. I have 1Y minus 5Y, that's negative 4Y, equals negative 16. Divide by negative 4, so Y is 4. Take that, plug it back in. I would plug it into one of these equations. I just used the eraser. One of these equations where you got everything on the same side. It's going to be a little bit easier. So I'm going to plug it in to the X minus 5Y equals negative 10. So I think that's the easiest for me. So I'm going to say x minus 5 times 4 equals negative 10. So I have x minus 20 equals negative 10. Add 20 to both sides. And so x is 10. So those are my two numbers. All right, 36. What are the three possible scenarios when solving a system of equations? Sketch an example of each. All right, so for a system, we can have one solution, we can have no solution, or we can have infinitely many solutions. Okay, one solution would just be two lines that intersect. Okay, and the intersection is the solution. No solution would be two parallel lines because they don't ever intersect. And then IMS, that's going to be the same line. It's going to be one line on top of the other. 37. Given the equation of a line, negative 4x plus y equals 2, write the equation of a line through the origin that is perpendicular to that line and parallel. Okay, remember perpendicular means opposite reciprocal slope, but we don't know the slope yet because it's done in y equals mx plus b. So I'm going to get this in y equals first. So I'm going to add 4x to both sides. Whoops, 4x. That gives me y equals 4x plus 2. Okay, now if I have perpendicular lines, okay, my slope here was 4, which means my opposite reciprocal slope of 4 would be negative 1/4. That's the slope I'm going to have to use. Now we have a slope, and then they're giving us the origin, which is 0, 0. So a point and a slope, that means I put it into point slope. So I'm going to have y minus 0 equals negative 1/4 times x minus 0. So that's just going to be y equals negative 1/4 x after you work that out. Parallel would mean I use the same slope, which means I need to use a slope of 4. So I'm going to have y minus 0 equals 4 times x minus 0. If I work that out, I get y equals 4x. I worked that one kind of fast, so go back and watch that if you need to. 38, this is a compound inequality, which means I can do a shortcut here. I can just subtract 9 from each side, and that gives me negative 10 is less than n is less than 8. Okay, and it says to graph this, so I'm going to draw a number line. I'm going to put a negative 10 and an 8 on there. Okay, I need everything, if I read this backwards, I need everything greater than negative 10, and then I need everything less than 8. So everything less than 8. Okay, so this is one where they overlap because it's an and. They share that in the middle. So it's everything from negative 10 to 8. That's your graph. Just this, this graph right here would be your final answer. All right, and the last problem. Alice and Alma have to fill a workbook. Alice has already completed 3 pages and can do 7 pages per hour. Alma has completed 11 pages, but can only work at a rate of 3 pages per hour. Eventually, Alice will catch up and the two will be working on the same page. How long will that take? How many pages will they will each finish? All right, so we need Alice to equal Alma. We're trying to figure out when they'll be the same. So it says Alice, she's already completed 3, and she's doing 7 per hour, so 7H. Alma has completed 11, and she's doing 3 per hour, so 3H. Now I'm going to solve this. So I'm going to subtract 3H. So I have 3 plus 4H equals 11. Subtract 3. So I have 4H equals 8. So divide by 4. So H is 2. So it's going to take them 2 hours for them to be on the same page. Now, how many pages will they finish? Just take either one of these side of the equations. So I'm going to take Alice, and I'm going to plug in 2 for H. Doesn't matter which one I plug it into, because that's when they're going to be the same. So I have 3, I have 3 plus 7 times 2. 3 plus 14, which would be 17 pages. Okay, I know that was really fast, and I'm sorry this review is really long. But if you just sit here and watch this whole review, make sure that you go back and do the review on your own, because these systems take a little while, so make sure you really know what you're doing.